Okay, Arkady, you've got... sorry, no. The stage. I'm sorry. Go ahead.
All right. Hi, this is easy GL and Vulkan tests with Shader Runner and Amber. I am Arkady Goldmans-Orlov. I work for Igalia on Mesa development, so making graphics drivers work. Why is this interesting? Well, to make graphics drivers work, you have to test them. We have wonderful test suites. We have Piglit, we have the Chronos conformance test suite, but they're big and complicated, and they're full of C code or C++. But inside that, those tools, there's some neat little scripting tools. There's Shader Runner in Piglit, and there's Amber included in the CTS. And they're quite useful both for developing new tests, so you can get a test going a lot quicker, and for debugging code, writing a quick little test to see what is it doing wrong and try to kind of narrow down the test case, for example. So yeah, programming is hard. Let's go scripting. So rather than write a whole program, in C or C++ to deal with, all the basic stuff that it takes to get going with OpenGL or with Vulkan, which is even more work. You can just use these scripting languages. They take care of all the hard stuff for you. It's very convenient if you want to, for example, just run a shader. You can do that quite easily. So for OpenGL tests, Shader Runner is part of Piglit. For scripting Vulkan, Amber is used in the Vulkan CTS, but it's actually a separate project, and you can run it by itself outside the CTS. So where do you find Shader Runner? When you build Piglit, it can be found in bin/shader runner. You run it just like that. You give it the name of the test script that you want it to run. And by default, it actually draws into a window and keeps that window up on your screen so you can see the result of your test and maybe visually inspect what's going on if it's doing something wrong. But it also has a mode to run automatically and just print the pass or fail result and not keep the window up on your screen. And it has a mode to draw off screen, so you don't have windows popping up on your screen. For whatever reason, you have to pass those options at the end after the name of the shader test that you want to run. But those are handy options. So here's an example of a Shader Runner shader test file. It starts with a require section where you just tell it what version of GL you need, what version of GLSL. You can also specify GLES. After that, you specify the shaders for, if you have a vertex shader, you can specify that. If you don't care to do anything interesting in the vertex shader, you just say pass through, and it just passes through the coordinates and doesn't do anything interesting. Then you have your fragment shader, which is just you write some GLSL code. And it supports all the other usual shader stages as well. I don't think it does ray tracing yet. After that, you have your actual test script, which is a series of commands. So here it sets the clear color, does a clear, draws a rectangle, and then the probe command is what actually does sort of the testing part and checks the values that got drawn. In this case, it checks that all the pixels got this color. There are many other commands. Just as some examples, there's a compute command, so you can run a compute shader. It supports various types of buffer objects, SSBOs. You can create SSBOs. You can set data in SSBOs. You can probe them after you've run your shader to make sure the right things have been written. There are various different things that you can do with probe. You can probe rectangles that are, sub-rectangles of the frame buffer to make sure that those are right and do more complicated probes. Unfortunately, these commands are not particularly well documented, and the only real reference for these commands is actually the shader runner source code. There's a giant chain of if-else statements. That's the parser, and that's kind of the only place where you can find all of these commands. But there are also lots of shader test files that are included with Piglit that have all of these commands and examples of how to use them. So you can look at those for inspiration. And of course, you can always add your own commands if you can't find what you want. So for Vulkan scripting, there is Amber, which was created by Google and was kind of explicitly meant to be a shader runner-like thing, but for Vulkan. It has its own GitHub project, but it's also integrated into the Vulkan CTS. So it's actually, if you have the Vulkan CTS source code, you can find it in this external/Amber directory. And for its script files, it supports multiple syntaxes. It has its own Amberscript syntax, and it also supports basically the same shader runner syntax, but for Vulkan. And there are examples of each included with the Amber source. So here's an example of the Amberscript syntax. It's just a different syntax for kind of much the same idea. You have your shaders. You can also have a pass-through vertex shader if that's what you want. Then you have your fragment shader in GLSL. You can actually have your shader in a number of different formats. It can get compiled through GL slang validator, or you can have an actual just SPIR-V binary or assembly shader as well. Then after that, you have your buffers, in this case, just the frame buffer, but you could have other kinds of buffers. You could set contents in them. Then you declare one or more pipelines, which, then you tell it what shaders you want to go with that pipeline, what buffers you want to go with that pipeline. And finally, you run the pipeline. You tell it to draw a rectangle. You can tell it to draw other things. And the expect command is how you check the results. In this case, it's the same check that all the pixels in the frame buffer have this color. So more Amberscript commands. You can have compute pipelines. As I mentioned earlier, you can specify initialization data for buffers. So you can, for example, you can fill it a buffer with zeros or ones or whatever value you want. There's even a command to fill a buffer with an incrementing value. And then with expect, you can also do a number of other things. This RMSE command is interesting because it computes the root mean square error between two buffers and checks that it's within the given tolerance. But there's lots and lots of commands, and they actually are documented. There is an actual documentation file that describes all of the commands in the source code in the doc directory. Other things about Amber, it supports Vulkan validation layers and actually tries to use them by default. You can disable them, though, if that's not what you want. One very useful feature of Amber is that you can dump any buffers after your script has run to a PNG file with these capital I and lowercase I options. It's very useful for debugging. You can actually dump any number of buffers. So for example, when you have multiple render targets, you just dump all of them. You have a bunch of PNG files. You can quickly check them to see what's going on. As I mentioned, shaders can be in SpearV, GL, or GLSL. The latter get compiled with GL slang validator, on which Amber actually depends. You can have multi-step tests. So a common thing that I've seen is, having two different pipelines drawing to two different buffers, and then maybe you can compare them with an expect command, or even have a third step with a third pipeline that actually compares the two buffers in a shader and then draws green for good and red for not good. So that's an interesting thing you can do. And I'm sure there are many examples included with the Amber source, as I mentioned, or in the Vulkan conformance test suite, and more tests are being written with Amber because it's easier. So in conclusion, I found these tools to be very useful for writing quick tests, especially, for example, when I'm working on the compiler. All I want to do is run the shader and see what it does. I don't really care about anything else. Sometimes maybe I just want to compile the shader, and this is a very quick way to do that. It's very useful for debugging. For example, I have a failing test in the CTS, and it has some complicated shader. I can slowly cut it down to see what part is actually going wrong, what's going on there, where to fix it. And hopefully, if you haven't heard about these tools already, hopefully you'll find them interesting and useful. And hopefully also we can make the magic of open source happen. And some of you may want to improve these tools, which would be great. And I guess that's it for me. Any questions?
So far, we do not have any questions, or we can wait a little bit.
So a question for kind of the audience in general. Are you aware of these tools? Have you used them before? Do you think they're useful?
That's going to be an interesting way of answering.
Curious, yeah.
Maybe you can use the XDC 2020 channel to just say yay, nay. Get a feel.
I feel like this isn't nearly as exciting as ray tracing.
So Liud was saying that he's been using Shader Runner. I guess anyway, it would be quite difficult for people to, for us to see. So I guess people are just self-censoring.
Yeah. Well, anyway, hopefully people will find this useful. It says it helped me learn GL, which is definitely kind of a good way to get into GL, because you don't have to do all of the setup. It kind of takes care of a lot of things for you.
That is true. It was much easier if you want to set a pipeline. Very easy. And Samuel also has been. Okay, well, thanks a lot for the talk, Arkady. And the next talk is and the last talk is gonna be by AMD. Don't bake your graphic cards. So, talk to you. It's in 14 minutes. So, see you then.